Hi everyone, I'm Pranoti, host of Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials or nanoscience, who tweets from the Real Scientists Nano Twitter account, which is realsci_nano. Hi everyone, my name is Pranoti and I'm your host of Under the Microscope podcast where we have a new materials and nanoscientist every week. And today we have with us Reza Rouzegar, who is a PhD student at the Free University of Berlin, which is of course in Berlin, and is also affiliated with the Fritz Haber Max Planck Institute in Berlin. So is wearing two hats and doing super cool research. And let's dig in. Hi, Reza. How are you?
I'm fine, Pranati. Thanks for having me.
Very excited to learn more about your research. So let's start with your career journey so far. You mentioned in the short podcast that you started as an electrical engineer, then telecommunications masters. And
Exactly.
so tell us, how did you end up being a physics PhD student at the Free University Berlin? Tell us.
Yes, so I studied electrical engineering in my bachelor in Shiraz University back in Iran because I'm Iranian. And then during my bachelor in electrical engineering, I learned how to design circuits. So it starts from DC AC circuits, and then you learn electronics, and then you like to do them a little higher frequencies. So you learn to do them in the RF radio frequencies. And then when you become a little cooler, you do them in the megahertz frequencies in the later semesters. And then when you're in the last year, you start also learning them in the gigahertz regime. For example, you design waveguides, antennas, and these things. So, and later I decided basically to go to Italy and study my master. And basically in Milano, I studied basic telecommunication engineering, which was more doing also the basic photonics. So you learn to design circuits with light, a little higher frequencies.
Okay.
And also I learned during the master a lot of signal processing, machine learning. Uh, and then I realized that basically for designing circuits, I have the full spectrum, but there is something missing, which is a terahertz gap. So basically, I knew design circuits from all the DC to gigahertz, and then photonics, like basically IR. And there is something in the middle which is missing, which is terahertz. And then I came across basically this research group that they were doing physics, like magnetism and terahertz. And this terahertz was really exciting for me. And say, oh, I will learn terahertz. Why I believe terahertz is important, why I was excited, because I mean, in telecommunication nowadays we're moving towards 6G, and in 6G you already start to using terahertz because in telecommunication you like to do things faster. There's a demand to do things faster and faster and faster. That's why it's really the spectrum is going towards higher frequencies. So I thought that learning basically terahertz would be also very exciting. But then there was physics, and I didn't have so much physics background. I always excited about physics. I liked it, and even I had some few courses in during my bachelor and master in physics department. But I was not a physicist. But I basically risked, and I came to Berlin, and my supervisor was super nice, and he basically we started working together, and I started my PhD. Then I realized, oh my God, okay, so physics is I really don't have this background. So it really took me 1 year to 2 year to really deep into all the details of the physics, and I'm so happy now that I can say I'm also a physicist now. So
Yeah. Okay. Wow.
yes, yeah.
Wow, that is really cool. So, when are we getting the 6G?
So basically, according to industry, it should come in the course of 5 years because now they're implementing 5G, so it should come soon.
Oh,
Yeah,
okay. So we will have even faster internet.
even faster,
Even faster. Okay,
even faster.
even faster. Okay. Um, Okay, that I look forward to that. Just faster and better and stronger. Definitely, I'm definitely looking forward to that.
Yeah.
So, Reza, your current research, you already spoke about it in the short podcast, what it is. So, what I want to understand from you is, so the field of materials and nanoscience is quite broad, right? It's quite
Yeah.
a wide field from biology to biophysics and to basically automotive industry, semiconductor industry, everywhere materials and nanoscience fits. So your research, where does it fit in this big picture of materials and nanoscience?
Yes. As I said earlier, my research now during the PhD focuses on the spintronics.
Mm-hmm.
So, and in order to do a spintronics, you need to do simple spin operations, which are, for example, turning a spin around, moving spins through the space, and detect the spins.
Right.
So now I would tell a little about the first operation to turning a spin around, which I have done a lot during my PhD. So imagine you have a spin and you basically want to turn the spin around. You can put it in a magnetic field and basically you apply torque to this spins. And what happens is that the spin basically process. So it takes some time for spins to process, and then it changes the direction.
Mm-hmm.
And this is usually happens in a nanosecond region.
Whoa. Okay.
Yeah. And we think that even nanosecond is slow because
Oh.
yeah. Because in MRI, for example, this is in gigahertz. So because nanosecond, if you go to frequencies, gigahertz. This is exactly, for example, how MRI machine works
So 10 to
based
the
on
power 9.
exactly.
Mm-hmm.
And then basically people were using it for a long time, but then in the 90s something happened in the 90s. So there was one scientist, Bourapeur, who basically found out that even you can basically turn the spin around much faster
Mm-hmm.
in hundreds of femtoseconds, much faster.
Femto
And
is
there
power minus 15.
exactly means thousands and millions times faster. So of course in industry there were so many people very interested because means that you can write data much faster.
Correct.
That's why there was a boom in the magnetism science. People were wanted to do things much faster. So what happened? Let me explain what does it mean. This is called ultra fast demagnetization because turning the spin in general means demagnetizing a material. For example, you have a thin film, for example, what I work is like usually tens of nanometer, 10 nanometer
Mm-hmm.
film, and then you bring a permanent magnet on top of the, for example, iron film, and you know that when you bring a permanent magnet close to a film of iron, you magnetize the iron. And
Correct.
then what I do in the lab, I have basically a femtosecond laser. I have a short pulse of 10 femtosecond. I
Mm-hmm.
shine my laser light into the thin film of iron, and we see that the iron demagnetizes. So the magnetization of iron shrinks
Hmm.
in a very fast manner in hundreds of femtoseconds.
Mm-hmm.
So since the 90s, there is a very big debate what is the microscopic origin of this ultra-fast demagnetization. And
Mm-hmm.
there has been a lot of application of this. And still, till today, there is a big debate. There is no consensus of exactly what's happening.
Okay. Okay. And how does this relate to the 5G? So I'm going to ask you a stupid question here because this field is completely new for me. So the 5G is 10 to the power 15 or 10 to the power 9? Like, is it the nanoseconds that we are working with here or femtoseconds?
5G, you mean the mobile industry? This is
Yes.
what you mean? Okay, so for the 5G, still we are using gigahertz regime, and in 6G, hopefully we will go to the terahertz. But I will come to this point very soon, that how this ultra fast demagnetization
So that
can
goes
be related to basically terahertz.
okay.
So exactly. So what I do, this is exactly this is what has happened. But what is my research topic exactly? So I know that when, for example, a thin film of iron demagnetizes, the magnetization shrinks. And this is a source of terahertz radiation. So when a magnetization shrinks, it emits terahertz.
Okay.
And then in the lab, I'm very good at measuring the terahertz because I'm working in the terahertz group. So by measuring this terahertz field, I can gain access to the magnetization dynamics.
Ah.
So basically, a terahertz for me is a tool to understand what's happening inside iron.
Mm-hmm.
And then by this, I could gain new insights and realize, for example, the driving force for this ultra-fast demagnetization can be a spin voltage. It means that when you shine laser into your system, you immediately develop a spin voltage, and this spin voltage drives ultra-fast demagnetization.
Uh-huh. Okay. Okay.
Yes,
Oh,
and
wow.
it radiates terahertz.
Okay, all right. And I hope you will do multiple threads on Twitter to explain this step by step because this is a lot for me
Yeah.
also to take in. But yeah, that sounds really cool. And it sounds to me that you're involved, not just right now, but also you mentioned you did an animation of your masterwork.
Yes.
So it sounds to me that you are involved in a lot of very interesting research projects. So this is a difficult question, right? If you have to pick one research project that
Mhm.
you're most proud of, or the most fun or quirky one, could you
Uh-huh.
do that for us and explain it to us in simple words in the section we call In Other Words?
Sure, of course. Uh, as you said, it's difficult to choose one of them, but I would prefer to basically to talk about what I did during my PhD, the stuff that I just worked on.
Mhm.
Basically, as I said, you have this your iron film and you demagnetize it, and then there is a very interesting application that if you now attach a non-magnetic material to the iron, for example, so imagine platinum. Then you have a bilayer of iron and platinum. And again, you shine your laser into the iron. As I said, iron wants to demagnetize, but this time something very interesting happens. The spin move in space. The spins go from the iron to the platinum.
Mhm.
And this is called basically you generate a spin current from iron to the platinum, and something interesting happens inside the platinum that it's transformed this spin current into a charge current, and then this platinum emits a lot of terahertz, a lot. Like it gives a big terahertz emission, which basically, when I joined this terahertz group, they already developed a device which is called a spintronic emitter, a spintronic terahertz emitter, which is one of the best emitters that basically you can use in terahertz spectroscopy. And even recently, my colleague and my supervisor found a company that basically they are selling this emitter. So my research directly related to application. So at the beginning, when I came to the group, we basically had some idea how this spintronic emitter works, but then my research was really focusing what is the driving force and how can we optimize it. So during my PhD, I tried to understand, and we realized that also the mechanism here is very similar to the ultrafast demagnetization. You generate a spin voltage, and this spin voltage give rise to this big terahertz emission. And then I could use this insight to even improve the spintronic emitter. So we recently, with some designs, we could improve it by a factor of two, like 100% improve of this emitter, which is now coming to basically you can even buy them online, like from this company.
Ah, okay. Wow. That is so cool. And I hope you will talk about the company when you're taking over the account.
Of course,
Of course,
I
you
will advertise the company.
of course advertise the shit out of the company.
Yeah.
Okay, excellent. That is awesome. So, uh, I mean, Reza, this is the first time we are speaking, but already I'm getting the feeling, and I'm quite sure about it, actually, that you really love the research aspect of being a scientist. However, that is one part of being a scientist, right? There are multiple other parts or phases of being a scientist. So, what else do you enjoy other than the research itself, as your life as a scientist?
Yes, so I guess you guessed it very correctly. I really enjoy what I do, and the reason is that basically our being a scientist means that you do very diverse activities during a day, you know? So you go to the lab and you do things. That's really important for me. So even though I was engineer, but usually you basically sit on the computer and you try to code and do, like it's more, but when you go to the lab, you really build things and it's really great feeling. And it's like it's impressive that you can really measure with the very, very fine, basically resolution of femtosecond, which is mind blowing. Like 1 second for humans, it's very fast, but then now divided by millions and millions and millions. It's just, when you measure these things, it's kind of impressive. I really like it. I
Mhm.
didn't design it, but I learned how to do these things. But still, it's great.
Mhm.
And of course, it's not everything. You're not always in the lab, and then you have to basically analyze your data, and you have to be a really good storyteller. So
Mhm.
you should be able to communicate your result, to tell a story. Because when you want to present it to other people, in order to be understandable, you have to make one story out of it. And I really like this part of to be a storyteller, to tell a story. And then the next one is that you also should be a good writer. You have to, when you write a paper, you should know how to basically write things, how to develop your stories. And at the end, so when you're a scientist, you travel a lot, and you cannot do your job alone. You need to basically get on board other people's. You need other people to do your research, because you cannot do everything alone. So you need a lot of collaboration, and I really like this aspect of our job, because you go to the conferences, you talk to the people, you basically make arrangements, you send samples, and you receive sample, you measure for this colleague, and it's really nice collaboration. So you really learn how to work in a group, with other people. Yeah,
Mhm.
these are the aspects that I really enjoy of being scientist.
Mhm. Mhm. Okay, I remember all of those, and that is really, I completely agree with you. Um, so, Reza, you also seem to have gathered a lot of experience, of course, as being a scientist. So, what advice would you give to researchers who are starting out today, or if you were to go back in time to the younger Reza, what advice would you give if you were to start out today?
I, I guess I don't know if I'm in a position to give advice, because
Of
I'm
course.
already a very, very like senior scientist. I really don't, yeah, not in a position.
Okay, let me.
But maybe I can tell
Okay.
my past myself, or maybe some people that.
Yeah.
So uh, something about me that I really changed. So it was electrical engineering, then the different kind of engineering, telecommunication, and then being a physicist. So I guess you should be very bold and courage and be up for changes. It seems scary, and it also I agree that it needs to get involved more, and basically you have to try harder. But when you learn different things, you have a better perspective of what's happening around you.
Mm-hmm. Yeah, definitely, definitely. And you were saying at the beginning, when I was trying to interrupt you that you do not have experience. Dude, you worked in 3 countries already, and I do not even know how many different collaborations and labs. So you definitely have a lot of experience, and you definitely can give amazing advice, which you already did. That be bold and be courageous. Um,
Thanks.
that is very cool. So Reza, I hope your research experience has been wonderful so far and will continue to be wonderful in the future well, as long as you decide to stay in the research field. However, if you had 3 wishes to improve your research experience, what would you ask for? And I'm not promising anything, okay?
Okay, so I guess I would. So instead of having my personal wishes, I would prefer to say more collective wishes,
Mhm.
how the science community in general can be improved.
Mhm.
So my own experience, one of the things that I guess it can be really improved is publishing process. So because there's a fundamental problems that so we all agree that basically it's very important to publish because your career depends on it, and then basically science advances really depends on publishing really good papers, really nice papers, but then the publishing process doesn't work effectively. So what happens is that you submit a paper, and basically they send to reviewers, but most of the time, even good scientists, they are so busy to review papers. So I know so many good scientists that really don't have time. So at the end, I guess it should be necessary, some part of your responsibility, that everybody, all the good scientists, try to review papers, because at the end, if good review basically coincide with a much better quality of a paper.
Mm-hmm.
But the problem is now that there is no so much reward to review a paper. So nobody basically appreciates you so much that you put a lot of time, because reviewing a paper needs a lot of time. You have to really spend a lot of time if you really want to review good. So and that's missing. So I would say something needs to change. That, like, people invest more time in basically reviewing process. And the other thing is that basically, of course, everybody likes to publish in Nature and Science. And somehow, because of this high demand to publishing there, the editors in these glossy journals are so picky. And now this is like a fashion. They only try to get basically accept the papers for review when they have a very sexy title. They really go with the trends.
Mm-hmm.
So that's something problem. It's a fundamental problem of science. This is not how it should be, I guess.
Mm-hmm. Mm-hmm. Okay, so the publishing process needs to be improved. Okay, that's wish one. Second wish.
I would say so. As a scientist, I mean, we love, usually all scientists, they love their job. That's why they're doing it. And they're more difficult compared to for example, if you have a job in a company. But somehow, something which is missing is that as a scientist, you don't have a job security.
Hmm.
So I mean, I studied engineering. I know my friends who graduated with me after master. They're already in the industry and they have a full contract, and then they're already a manager, and basically they have a job security. But as a scientist, you always question, okay, so what should I do next? And then you end up trapped, because in science they expect you to travel. For example, after a PhD, you go to a postdoc, to a different country. You're just moving around. You're yeah, somehow I guess you don't have a job security, and the expectation from a scientist is a lot. So the third wish is that they expect you to do all of your duties very well. You travel a lot, you basically work a lot, you go to the lab, and then so the workload is so much. I mean, it's fun. If nobody even asked me or pay me, probably I would do the same. But still, it's nice to have some security, you know?
Absolutely, absolutely. I agree. So the publishing process, the career not being dependent probably
Yeah.
on the research output, which is measured in terms of number of papers and the impact factors and all of that. And the third being the job security.
Yeah.
Very, very important wishes, I would say, and I hope they come true in the near future. I
I
really
hope
hope
so.
so. At least we make some progress there. Reza, this was really nice. I really enjoyed speaking with you. I have one last question for you before I let you go,
Sure.
and that is, what are your learnings from the magnificent year or times that we are living in since 2020?
Okay.
Because I'm not going to say the P word or the C word. You know what I'm talking about. Listeners also know what I'm talking about and referring to. What are your learnings from the times?
Okay, that's a quite difficult question. If I have to mention something, I would say that before 2020, we had a lot of freedom. We did everything without even, I mean, taking it for granted, and suddenly we lost all of our freedom, many of them during these last 2 years.
Mm-hmm.
And somehow, I guess for me, it was really nice to appreciate the freedom and don't take it for granted. And then I was also amazed during these 2 3 years that basically humans are impressively adaptable. So after this pandemic, we were at homes, and immediately we were basically finding new ways to communicate. I mean, we had many online conferences, online poster sessions. We were really good in adapting, as our ancestors adapted, and now we are here.
True, true. That is true. Absolutely. You're absolutely right. We are very adaptable and do not take things for granted.
Yes,
Very, very true indeed. So thank you very much,
you're
Reza.
welcome.
It was amazing speaking with you. Looking forward to having you on Real Scientist Nano. Thank you.
Thank you so much. It was so fun to be here.
Thank you for listening. I also want to thank my team, Johanna, who is our news editor and curator liaison, Swenya, who is our podcast engineer and curator liaison, Lucia, who is our media and website coordinator, and myself, Pranoti, being the owner of the Science Talk and host of Under the Microscope. To know more about us, visit our website, thesciencetalk.com, and follow us on Twitter at realsci_nano.